All right, I'm back today, and we're going to be talking about exponential functions. You may want to go really slowly through this video and pause it and think about what I'm saying, because there's a lot of new things that we're going to learn today. All right, so this is an equation of an exponential function. Y equals A times B raised to the x power. Because that x is because we're raising to the x power, that's why it's exponential, because the x is the exponent. All right, so that's the exponential function. Make sure that you understand what it is. Write it down, please. Now we're going to look at b today, and if b is greater than 1, all right, then it's an exponential growth, and that means that it's increasing in value. All right, and if b is less than 1, then it's an exponential decay, meaning that it is decreasing in value. All right, and then we have a new word for you, and this word is asymptote. And asymptote is a line that a curve approaches. So our line that we're going to be graphing is curved, all right? And asymptote is a line that the curve approaches as it's going toward infinity. It never ever is going to cross or touch that asymptote. All right, so be thinking about this as we talk about the next few slides, and think about what that means, that that line is never going to cross or touch this asymptote. All right, let's first of all get started. All right, so we're going to graph. All right, we're going to start just like we have been. And we have this equation. It's an exponential equation. I know it's exponential because the 2 is raised to the x power. All right, so now, just like in a parabola, I need to make 5 values for my x. And we're going to keep it pretty simple. And you can use your calculator. And you should have a y to the x power on your calculator, and that's how you're going to put things in. So we're going to start out with x being the -2. Remember, x is your exponent, and so we're going to start out with 2 to the -2 power. Now, if you remember back in chapter 1 or section 1, we talked about negative exponents, and that meant that I was going to put 2 in the denominator raised to the second power, which means it's 1/4. Well, we know that 1/4 written as a decimal is 0.25. If you put that in on your calculator, that's what should have come out. Then I'm going to do 2 raised to the -1 power, and that's going to give me 1/2, or 0.50. Anything raised to the 0 power, we learned back in section 1, was 1. All right, so 2 to the 0 power is 1. 2 to the first power is 2. And 2 squared, or 2 to the second power, is 4. All right, so now let's go ahead and graph those points. Now notice as we went from left to right, the values were getting bigger, meaning that it's increasing, going from left to right. Okay, our 2 is greater than 1, meaning it's and increasing, meaning that it is a growth. All right, so now let's go ahead and draw in our line, connect our dots here. Okay, here's what it looks like. Notice it is a curved line. All right, and it's getting bigger and bigger. There are arrows on both the left side and the right side. All right, so let's look at this again. This was our exponential equation. Notice that the b is connected to the exponent. The a is being multiplied by the number that is connected to the exponent. So let's look at our equation, y equals 2 to the x power. Notice I didn't say anything times 2 to the x power. I just said 2 to the x power. That means that a is 1 and b is 2. And because b is greater than 1, that means it's an exponential growth. All right. Now, let's look at what the domain is. Remember, the arrows are going from right to left. All right. They're going, and as I'm going to the right, my numbers are getting greater and greater, but it's also getting further and further out to the right. And it's going to just keep going a little further right, and a little further right, and a little further right. And notice my arrow on the left side, it's going to keep going a little further left, a little further left, a little further left. That means my domain is all real numbers. All right. So think about that for just a second. Now, let's clear off some space here and let's talk about what else is happening here. So remember when I told you about an asymptote? An asymptote is where the line, the curved line, okay, keeps getting closer and closer but never touches a line here. I'm going to tell you this line is going to keep getting closer and closer and closer to the x-axis. All right, that means that the asymptote is going to be y is going to equal 0, meaning it's never ever, y is never ever ever going to go below 0, ever. Now I'm going to talk to you about that in a couple slides, but I want you to keep that in mind. I'm just telling you right now that the asymptote is 0. I'm going to tell you how to find it in just a few minutes. So hang on. I promise I'll make it clear. So remember that line is going to keep getting closer and closer to the x-axis without ever touching or crossing it, meaning that y will never be less than 0. That means that my range then has to be greater than 0, because it can't be greater or equal to 0, because again, my line is never ever going to be below 0. All right, it's going to keep getting closer and closer to 0 but never touching it. So the range is greater than 0. Okay. Let's do another problem. Let's look at problem number 4. Problem number 4 looks like this. Y is equal to 1/3 raised to the x power plus 4. What do you notice different about this particular problem? Well, there's a couple things. First of all, my b is less than 1. All right. So that means that it's going to be an exponential decay. I don't have to graph it to know that. I know that the b is less than 1. But something else I want you to notice is that I'm adding 4. All right? Before we weren't adding anything. And the same as not adding anything means that we were adding 0. Right, that's going to be important in just a few minutes. So let's go ahead and graph this. And again, I'm going to use the same numbers for x. I want about 5 of them. I could do more than 5 if I wanted to. And again, you can put this in on your calculator. You would have to do 1/3 to the -2 power equal and then plus 4. And you should get 13 when you do that. I'm actually just going to give you the y values for this one because I think you can put it in on your calculator. You want to pause and then see if you get the same answers I do. All right. When I use 1/3 to the -1st power plus 4 is 7. 1/3 to the 0 power is 1 plus 4 is 5. Okay. 1/3 to the 1st power plus 4 is 4 1/3, or 4.3 repeating. And when I put in 1/3 to the 2nd power, is really going to be 1/9, right? Plus 4 is going to be 4.1 repeating. All right, so let's go ahead and graph those. And on my particular graph, I don't have 13, but I'm just going to kind of put it in up here somewhere. So -2, 13, -1, 7, 0, 5. That's my y-intercept, by the way. 1, 4.3, and 2, 4.1. And there's my line. That's when it's curving. Now, what do you notice? Notice that, again, the domain is all real numbers, but look at that line. The curve is going toward what number? It's going toward 4, where y is equal to 4. All right, so my domain was all real numbers, and my asymptote is y equals 4. So where did we get the 4? Well, it came from what we added to our original equation. So we added 4. Remember I said in the last one we were adding 0? So we're adding 4. That means whatever you're adding or subtracting is your asymptote. And if you're not adding or subtracting anything, your asymptote is going to be y equaling 0. So in the case of exponential equations, whatever I'm adding or subtracting is my asymptote. And then from there I can get my range. That means that the range, all right, is going to be greater than 4. All right, a lot to think about. Could you finish number 2 for me on the front page? And until tomorrow, bye-bye.